This video is part 3 of the chapter Probability. In part 1, I introduced the chapter and discussed basic terms and properties of probability and took some common questions as examples. In part 2, I took questions on tossing of coins and discussed solutions on finding probability in different ways. In the current video, part 3, I take questions on throwing of dice and finding out probability with solutions in different ways. Let's start. As we know, total of 6 faces are there in a cubical dice, and each face is marked with different counting numbers from 1 to 6. So total of 6 possible outcomes are there in throwing a dice. Now let's check questions one by one and find probability. Question number 8. A dice is thrown or rolled once. Find the probability of getting the followings. Number A. Find the probability of getting an even number. As we know, points in the range 1 to 6, there are 3 even numbers, 2, 4 and 6. Hence, total number of favorable outcomes is 3. Hence, probability is 3 by 6, and in simplified form, it is 1 by 2. Number B. Find the probability of getting a number less than 8. As we know, points marked in the dice are from 1 to 6, and all these points are less than 8. Hence, number of favorable outcomes is 6. Therefore, probability is 6 by 6, and in simplified form it is 1. Number C. Find the probability of getting a multiple of 3. In the given range of points, only 2 multiples of 3 are there, and they are 3 and 6. Hence, favorable outcomes are 3 and 6, and the number of favorable outcomes is 2. Therefore, probability is equal to 2 by 6. And in simplified form, the answer is 1 by 3. Number D. Find the probability of getting a prime number. Prime numbers in the given range are 2, 3 and 5. Hence, the number of favorable outcomes is 3. Therefore, probability is 3 by 6. And in simplified form, the answer is 1 by 2. Number E. Find the probability of getting at least 2. It means 2 or more. I find favorable outcomes are 2, 3, 4, 5 and 6. Hence, total number of favorable outcomes is 5. Therefore, probability is 5 by 6. Let's handle the case of throwing 2 dice. In throwing 1 dice, the total number of possible outcomes is 6 to the power 1. But here 2 dice are there. Hence, the total number of possible outcomes is 6 to the power 2, and that is 36. Hence, 36 different outcomes are possible in throwing 2 dice. All the possible outcomes are shown here systematically using 2-digit numbers in a big square table. In each possible outcomes mentioned in the table using 2-digit number, the first digit represents the outcome of the first dice and second digit represents outcome of the second dice. Let's learn some more tips on all possible outcomes in throwing of two dice. A line drawn here from the top left corner of the box to the bottom right corner is called the diagonal or left diagonal. Elements falling on the diagonal 11, 22, 33, 44, 55 and 66 are called diagonal elements. And here we find that in each case the difference of points in two dice is 0. Here I take another line which is parallel to left diagonal and the elements falling 21, 32, 43, 54 and 65, and we find here that the difference of points in two dice is 1. I take another line parallel to left diagonal and elements 31, 42, 53 and 64. The difference of points in two dice is 2. Here is another line parallel to the left diagonal and elements falling in this is 41, 52 and 63, and in all these three elements we find that the difference of points in two dice is 3. Here randomly I take a line parallel to left diagonal and in this line the 13, 24, 35, 46. The difference of points in two dice is 2 only. So altogether it is clear that if we take elements in left diagonal, the difference of points 0. If we take any other line parallel to left diagonal, elements falling on that line, the difference of points you will find fixed. We can use this concept in solving some questions on probability. Next, all the elements falling below left diagonal, you will find some similarity are there, and that is here we find in all the elements below left diagonal the points obtained in first dice is greater than the point obtained in second dice. Next, the elements above the left diagonal, again similarity is there, and that is the points obtained in first dice is less than the point obtained in second dice. Let's see some more tips in the next screen. Here is another screen where a line drawn from the top right corner to the bottom left corner is called reverse diagonal or right diagonal. And here I find that the elements falling on this diagonal 16, 25, 34, 43, 52 and 61, and we observe here that the sum of the points in two dice is fixed, and that is 7. Here is another line drawn parallel to right diagonal and the elements falling on this line are 15, 24, 33, 42 and 51, and here we find that the sum of points obtained in two dice are fixed, and that is 6. Here I find that elements falling above right diagonal, the sum of points less than 7, and the elements falling below right diagonal, the sum of points greater than 7. So we could observe here that any line you draw parallel to right diagonal, the sum of points obtained in two dice is fixed. Let's take a question based on throwing two dice. Question number 9. In a single throw of two dice, find the probability of the followings. Number A. Find the probability of getting a doublet. It means the points obtained in the two dice same. In other words, difference of points obtained in two dice is 0. Since difference is fixed, we can look for a line left diagonal or a line parallel to left diagonal. Here is a line drawn that is left diagonal, and the elements fall on this diagonal are 11, 22, 33, 44 55 and 66. It means the points obtained in two dices are same, and total of 6 such situations are there. Hence, the number of favorable outcomes is 6 out of 36. Therefore, the probability is 6 by 36. And in simplified form, the answer is 1 by 6. Next question, number B. Find the probability of a number less than 3 on each dice. Observe the first two rows. First row says that the points obtained in first dice is 1. Second row says that the point obtained in first dice is 2. Observe the first two columns. First column says that the points obtained in second dice is 1, and the second row says that the points obtained in second dice is 2. The intersection of these two blocks says that the points obtained in first dice is 1 or 2, and the point obtained in second dice is again 1 and 2. It means the point obtained in the two dices are less than 3. So total of 4 favorable outcomes are there. Therefore, probability is 4 by 36, and the value in simplified form is 1 by 9. Number C. Find the probability of getting an odd number as a sum. Since the question is related to the sum of points, then I look for a line that is right diagonal or a line parallel to right diagonal where the sum is an odd number. Observe the first line parallel to right diagonal where the sum of points in two dices is 3, an odd number. Observe the second parallel line where the sum of points in the two dices is 5, an odd number. Observe the third line, the right diagonal itself, where the sum of points in two dices is 7, an odd number. Observe the fourth parallel line in which the sum of points obtained in two dices is 9, an odd number. Observe the fifth line where the sum of points obtained in two dices is 11, an odd number. And altogether I find that total of 18 such situations are there. It means the number of favorable outcomes is 18. Therefore, probability is 18 by 36, and its value in simplified form is 1 by 2. Number D. Find the probability of getting a total of 10, means the sum of points obtained in two dices is 10. Since the question is related to sum of points on two dices, therefore let's look for a line parallel to right diagonal so that the sum of points we get 10. Here is the line where the elements are 46, 55 and 64, and here I find the sum of points obtained in two dices 10, and total of 3 such situations are there. Hence the number of favorable outcomes is 3. Therefore probability is 3 by 36. The answer in simplified form is 1 by 12. Number E. Find the probability of getting difference of points 2 in two dices. Since the question speaks about the difference of points obtained in two dices, hence I look for a line parallel to left diagonal where the difference of points obtained in two dices is 2. Here is a line parallel to left diagonal where I find the elements fall on that having difference of points in two dices 2. Here is another line parallel to left diagonal where elements falling on the line having difference of points obtained in two dices is 2. Altogether 8 such situations are there. Hence the number of favorable outcomes is 8. Therefore, probability is 8 by 36. The value in simplified form is 2 by 9. Number F. Find the probability of getting prime number in both the dices. Observe row number 2, which says the point obtained in first dice is 2, a prime number. Observe row number 3, which says the point obtained in first dice is 3, a prime number. Observe row number 5, which says the points obtained in first dice is 5, a prime number. Observe column number 2, which says the points obtained in second dice is 2, a prime number. Observe column number 3, which says the points obtained in second dice is 3, a prime number. Observe column number 5, which says the points obtained in second dice is 5, a prime number. Let's find out situations where the element is the intersection of any pair of a horizontal line and vertical line. I find 9 such elements where points obtained in both the dices are prime numbers. Hence, the number of favorable outcomes is 9. Therefore, probability is 9 by 36 and the value in simplified form is 1 by 4. Number H. Find the probability of getting a number greater than equal to 4 on each dice. Row number 4, row number 5 and row number 6 says that the points obtained in the first dice is either 4 or 5 or 6. Column number 4, column number 5 and column number 6 say that the points obtained in second dice is either 4 or 5 or 6. And intersection of the two says that the points obtained in both the dices are 4 or more, and total of 9 such outcomes are there. Hence, the number of favorable outcomes is 9. Therefore, probability is 9 by 36 and the value in simplified form is 1 by 4. Number I. Since the question speaks about sum of points, hence we look for lines parallel to right diagonal. Observe the first line where sum of points is 2, a prime number. Observe the second line, the sum of points equal to 3, a prime number. Observe the third line where sum of points 5, a prime number. Observe the fourth line where sum of points we get 7, a prime number. Observe the fifth line where sum of points is 11, a prime number. I find here 15 such situations are there. Hence, the number of favorable outcomes is 15. Therefore, probability is 15 by 36 and the value in simplified form is 5 by 12. Number J. Find the probability of getting points in first dice less than second dice. Here is the left diagonal drawn where I find that the points obtained in two dices are same and the elements above left diagonal has the points in first dice less than the second dice, and total of 15 such outcomes are there. Therefore, the number of favorable outcomes is 15. Therefore, probability is 15 by 36 and the value in simplified form is 5 by 12. Number K. Find the probability of getting points in first dice minus points in second dice 4 or more. Since the question speaks about difference of points in two dices, hence we look for a line parallel to left diagonal. Here two such lines parallel to left diagonal are there, where the points obtained in first dice is 4 or more than the points obtained in second dice. Hence, the number of favorable outcomes is 3. Therefore, probability is 3 by 36. And the answer in simplified form is 1 by 12. In this video, part 3 of the chapter Probability, I took many questions on throwing of one dice and throwing of two dices. I tried to make the solution and explanations for each and every question fully satisfactory. I hope you would enjoy the video. I come with the next video of the chapter based on a new category. Thank you.